Hi everybody, today we're going to talk about the binomial distribution and I'm going to solve the problem using Desmos. So as a reminder, a binomial distribution happens when there are only two possible outcomes for our event. We think of each outcome as either being a success or not a success. The probability of success is constant, so no matter how many times we repeat this experiment, we would have the same probability each time. Our notation looks like X with a little squiggle, B in P. This tells us that our distribution follows a binomial distribution. The N is the number of trials we're going to do, and the P is the probability of success for each trial. So let's look at our example. A 20-question test has 4 multiple choice options for each question. If you guess the answers, we're going to find A, the probability of getting more than 12 right. In this situation, N is 20. That's how many times we're doing this experiment, which is guessing the answers. The probability of success is 1/4. There are 4 possibilities. Only one of them is right, so the probability of success is 1/4. I'm going to write that as 0.25.
In Desmos, we need to start by adding in the binomial distribution. You can do that 2 ways. You can type in binomial dist, and notice it goes from italics to regular font because it recognizes the command. Then it says it needs to know the number of trials, which is 20, and the probability of success for each trial, which we said was 1/4 or 0.25. The second option you have is to open the keyboard, go to the functions, scroll down until you find distributions, and you'll see binomial dist is there as well. Now that we have our binomial distribution in and we've put in our trials and our probability of success, we want to click on the arrow by cumulative probability. And our first question said we wanted to know the probability of getting more than 12 correct. So more than 12 doesn't include 12, it's 13, 14, 15, like that. So you could put in 13 to 20. That's one choice, or you can just say, oh, I know that more is to the right, so you could just click more and see how it brought the 13 over. This says we have a very small probability, it's 0.0002. If you want to be more precise, click on the arrow and it will show you more decimal places, and you can see that it really did round to get the 0.0002. It was 0.00018 originally.
The next part says let's find the probability of getting less than 10 right.
Less than 10 means that we're looking to the left. So I'm going to hit left. Left is going to show me less than. And then I'm going to put 9 because I don't want to include 10. We're not saying less than or equal to 10. We're just saying less than 10. This gives us 0.986. And again, you can click on the arrow if you want to see more decimal places.
The last one we'll look at today is the probability of getting 8 to 14 correct.
To get the probability of getting 8 to 14 correct, we're going to go back to enter, and this time we want to have a lower bound of 8 and we want to have an upper bound of 14. This says our probability is 0.102, which is 10.2%. One more time, we'll click on the arrow to show more decimals.